Okay, so in this video, we're going to connect our LED lights. The LED lights are going to be used to test various parts of the circuit, and they're also used as eyes. Now, LEDs are polarized, which means it does matter which direction the power flows through the LEDs. LEDs usually have one short leg and one long leg. The long leg is usually positive. And so we want to make sure that we match up our two long legs together. If we connect a short leg and a long leg together, it will have problems. They won't work the way they're supposed to. So we're going to look for our two long legs. Once we've got those two long legs figured out, we're going to bend them out so that we can connect them together. And so we're going to display those two legs there on the LEDs. And now that we know that they're two positives together, we're going to twist them together. Just twist them around one another. And we want to make sure that the twists are very tight so that we have a really good, solid connection. So just keep twisting those LEDs until those legs until they've been twisted around each other, probably about between 5 and 10 times. So then we have the negative legs of the LEDs on the outside, and the positive legs are twisted together on the inside. So now what we need to do is we need to connect the LEDs to the switches. And the way we're going to connect the LEDs to the switches is we're going to take some of the red wire that we had in our kit, and we're going to strip off about 1/2 inch of that red wire. And we're going to feed that red wire through the top connections. There's little tiny holes on each of those connectors on the back of our switches. So we're going to try and run this wire through those holes. And this is probably the trickiest wiring part in the entire bot because it requires you have to kind of bend the wire in a sort of a large loop or a hook shape to get it to go through both of the holes in each connection. So that's why we've got our trusty needle nose pliers there. And it does take a little bit of doing, but you can get it to go through both of those holes, and it does help to make sure that the connection will be a good one. So there we go. We got the wire to feed through both holes there. So then I just bent the wire up at a 90-degree angle to the connector that it's going inside of. I'll zoom in here just a bit to sort of make sure you can see what's going on. And in order for this particular SpoutBot build to work, we have to make sure that those wires are crimped or bent very tightly against the contacts. If there's a lot of space in between the wire and the contact, the bot may not function the way we want it to. So we're taking our needle nose pliers and getting it in to those tight spaces between the wire and the contacts and bending those wires tightly against the connections. And we're going to use our LEDs to make sure that connection is actually a good one and that power is flowing. So the next thing that we need to do is we need to trim our wire down just a bit. So we're going to cut about 2 inches off of our wire. The wire that's remaining should be about 1.5 inches long. And we're going to take off about a half an inch of insulation from that wire. So it's a 22 gauge wire, so it's really narrow. So we use the smallest hole on our wire stripper. And these are really low cost wire strippers, so you have to twist them a little bit to get the insulation to come off. Okay, so now we have our red wire there. We also have the red wire coming from our battery. So what we need to do now is we need to connect our red wire from our battery to the red wire we just connected to our single pole double throw switches. So we're going to make this wire we're going to take a little bit more insulation off of this wire. So we also made it a little longer. So it's about 2 inches long, and we're going to take about 3/4 inch of insulation off of this wire with our wire strippers. And you got to be careful because this is a stranded wire. It's not solid, so it's easy to break the strands when you're stripping it. So you want to take your time to pull the insulation off carefully so that you have all those electrically conductive strands still connected. So then we're going to take those strands and we're going to take that wire and we're going to wrap it around the solid core wire, which is the one we just connected to the switches. And the best connections are really tightly wound. So we want to make sure that all of those strands are very tightly wound around that solid core copper wire there. And so that's going to make it easier for us to connect the positive side of our battery to our LEDs and to other components as well. So now we're going to take our LEDs and we're going to connect the resistors to the LEDs. The resistors prevent the LEDs from taking too much current and burning out. So again, we're going to put the resistor leg at about 90 degrees opposed to the LED leg, and then we're going to just wind it around the LED leg. And we want to wind it around at least 4 or 5 times, if not more, to just make sure we've got a really solid contact connection with that LED leg. And again, that's the negative leg. And the resistors can go on either the negative or positive leg, but in this video we chose the negative legs, which are the outside ones. So again, just twist it all the way around until it's nice and firmly connected. It's important that those loops that we make with that resistor leg are very tight and firmly attached to the LED leg. Okay, so now that we have our LEDs set up, we can begin to connect them to the red wires which we just wound around. But before we do that, we're going to just test to make sure everything works. Let's move it here so you can see it. Okay, there we go. Yeah, so we're getting power through the wires, and we'll try the other side. This just makes sure that we've wired our LEDs correctly. Okay, so we have. And this is a low enough voltage circuit and low enough current circuit that we can just use our hands to connect these things. Okay, so now let's connect our LEDs. Now that we know that power can flow through there, we're going to wind try and wrap the wires from our red wires around our LED positive legs, which are the center legs there. So we're going to try and twist everything together. And this may be a little difficult. So if it is, you can always take your needle nose pliers and just crimp it on there and make sure that the wires are connected tightly. Now, the better this connection is, the more likely it's going to be reliable. So it's really important to make sure that that connection is solid. Okay, once we've got those wires twisted together and our LEDs are there, we can take a piece of aluminum foil and wrap it around just to help ensure that the wires are going to stay solidly connected and they conduct power. Now, you don't necessarily have to use the aluminum foil. It's just an added precaution. But we're basically it allows to make sure if there's any loose wire connections there that we still get electrical conductivity. But again, you don't necessarily have to have that. Okay, so now we're going to take some insulating material, which will be electrical tape, and we're going to wrap it around our aluminum foil and the twisted together wires, and that should help to hold everything in place so that we have a reliable connection. And it's just a little bit out of the screen. There we go. Moving it back into the screen. And you want to wrap that electrical tape as tightly as possible around that connection to help hold everything snugly in place. So now what we're going to do is we're going to connect our resistor leg and our black negative wire from our batteries to the 2 open terminals on our switches. And depending on which terminal you connect it to, the switch will turn it on or turn it off. And so one thing you want to be careful of is you don't want to leave it on there too long, because you can, when it's turned off, you can actually short the circuit, and that'll cause the wires to heat up. But it does allow us to test the LEDs and to make sure that all of our connections are good, and they are. So we're going to hot glue the red wires, which are the positive terminal wires, and that'll keep them from moving around and hold them against our single pole double throw switches there at the top.